In order to make sound decisions, it is important to organize data and present properly. There are actually three forms of data presentation: textual, graphical, and tabular. In this video, you will learn how to construct a table, specifically a frequency distribution table from scattered raw data. Let's consider this problem. A sample of 50 customers at a newly opened supermarket has been selected at random. The following data show the customers' ages. So we are given this raw data of customers' ages. Required: prepare a frequency distribution table. Let's have a step-by-step solution. Step 1 is to compute the range by deducting the lowest value from the highest value. In this problem, among the 50 customer ages, which one is the highest? This one, 60. Which is the lowest? This one, 10. So to compute the range, 60 minus 10. And we get 50. Step 2 is to compute the number of classes or class intervals. Usually, this is done by using this formula from Sturges rule. K stands for the number of classes or class intervals. We can use a scientific calculator or an Excel spreadsheet to determine this logarithm of n or log n. The logarithm of the number of observations, which is 50, because there are 50 customers' ages given in the problem. So our n is 50. So how do we get this logarithm of n? With Excel spreadsheet, since we'll be using a formula, so we start by typing the equal sign and type LO. Several formulas will appear. Just click this log 10. Then complete the formula by typing 50, which is the number of observations. Then close parenthesis. Press enter to get this figure. Let's round this figure off to 1.7. 1.7 times 3.3 plus 1 will give us 6.61. Rounded off to 7. So that means 7 is our number of classes or class intervals. Step 3 involves the computation of the class width or interval size. It is computed by dividing the range, which we computed in step 1, by the number of classes, which we computed in step 2. So the range of 50 divided by the number of classes of 7 will give us 7.14. Let's round it off to the next whole number, which is 8. So that means 8 is our class width. Finally, we can start doing the required frequency distribution table. The first column of the table is the class intervals. Recall that of the 50 customer ages given in the problem, the lowest is 10. So we begin with 10. Then add 8, which is the class width, which we computed in step 3, and subtract 1. So again, 10 plus 8 minus 1 will give us 17. Our upper class limit for the first class interval. In short, our first class interval ranges from 10 to 17. If you want to confirm if 10 to 17 should really be our first class interval, just count from 10 up to 17 with your fingers, and you will get 8, the class width. That is 10, 11, 12, 13, 14, 15, 16, 17. So, 8 numbers, right? Now, the second class interval begins with the number after 17, which is 18. Then, 18 plus 8 minus 1 equals 25. Then, after 25, we have the number 26. Then, 26 plus 8 minus 1 will give us 33. Then, after 33, we have 34. Again, 34 plus 8 minus 1 will give us 41. After 41, we have 42. 42 plus 8 minus 1 equals 49. After 49, we have 50. 50 plus 8 minus 1 equals 57. After 57, we have 58. 58 plus 8 minus 1 equals 65. The next column of the frequency distribution table is the class mark or class midpoint. Midpoint meaning the middle between the lower class boundary and the upper class boundary of each class interval. So, for the first class interval, 10 plus 17 divided by 2 equals 13.5. 18 plus 25 divided by 2 equals 21.5. 26 plus 33 divided by 2 equals 29.5. And so on and so forth. Up to this, the last class interval. The third column is the tally. You have to go through each of these 50 customers' ages. First is 12. Where does 12 fall in our class interval? Between this first class interval of 10 to 17. So, tally that. Okay? Then, go back to the given in the problem. Next, we have 23. Where should 23 fall in our frequency distribution table? Between 18 and 25. So, tally that again. Then, go back to the problem again. For 19, 21, 35, up to the last one, which is 52. After you do all the tallying, your tally column will then look like this. Based on this tally column now, we can do the fourth column of our frequency distribution table, which is frequency. 5 plus 2 equals 7. 5, 10, 15 plus 3 equals 18. 5, 10. So 10. Here we have 5. Same here, 5 also. Here 3. So write 3 here. Then this one 2. So write 2 here. For the first less than cumulative frequency, just copy this frequency. That's why we have here 7. Then 7 plus 18 equals 25. 25 plus 10 equals 35. 35 plus 5 equals 40. 40 plus 5 equals 45. 45 plus 3 will give us 48. 48 plus 2, we have 50. For the last column, the greater than cumulative frequency, we start with the n, or the number of observations, which is 50. Then 50 minus 7 equals 43. 43 minus 18 equals 25. 25 minus 10 gives us 15. 15 minus 5 equals 10. 10 minus 5, we get 5. 5 minus 3 gives us 2. What can we learn from this frequency distribution table now? For 1, 10 of the 50 sample customers who entered the newly opened supermarket are aged 26 to 33. Another is that 40 of the sample customers have ages ranging from 10 up to 41. Also, 5 sample customers are aged between 50 to 65. Thank you for watching.